Hello dear students, myself Rajesh Nanda, and today's topic is electric potential due to the point charge. Before proceeding to our topic, you are welcome to the समय 10 से 12 वाला हर घर बने पाठशाला। तो प्यारे बच्चों, हम उम्मीद करते हैं कि आप घर पर सुरक्षित होंगे और घर बैठे पढ़ रहे होंगे। इस महामारी के चलते आप लोगों ने ध्यान रखना है कि आप लॉकडाउन का पालन करें और बाहर ना निकलें, समय समय पर हाथ धोते रहें, सोशल डिस्टेंसिंग बनाए रखें। तो हम शुरू करते हैं आज का टॉपिक, इलेक्ट्रोस्टैटिक पोटेंशियल। फर्स्ट वी विल रिवाइज some previous terms like the line integral of electric field, electric potential and potential difference. Then for our study purpose, study work, that will be on electric potential due to a single point charge and electric potential due to a group of charges. Then we come to the revision work, line integral of electric field or work done by electric field. Negative line integral of electric field represent the work done by electric field on a unit positive charge in moving it from one point to another point in the electric field. That is given by WAB, integration of small work done dW, that is line integral, DL line integral of electric field between A and B. For that we have the three coordinate axes. Q positive charge is at the O center of the coordinate axis. AB are the 2 points having the position vector RA and RB. Another point P, here we have to calculate the work, small work done. The force at this point P, that will be equal to Q naught E at act on the test charge due to the source charge Q positive. It will be radially outward and tend to accelerate the test charge. To prevent this acceleration, an opposite force minus Q naught E has to be applied on the test charge. And the total work done by electric field on the test charge in moving from A to B in the electric field, that is given by WAB, integration of this small work done, line integral of electric field between A and B, that is equal to Q naught divided by 4 pi epsilon naught into 1 upon RB minus 1 upon RA. And this equation shows that work done in moving test charge Q naught from A to B along the path AB in electric field due to Q positive charge that depend only upon the position of these point and independent of the actual path AB. That is, the line integral of electric field is path independent. Therefore, electric field, that is a conservative field. The line integral of electric field over a closed path, that will be 0. This is another condition satisfied by the conservative force. Line integral DL of electric field around the closed path is equal to 0. Line integral of electric field, line integral of only static electric field, that is independent of the path followed. However, the line integral of electric field due to moving charge, that is not independent of the path because field varies with the time. Then in the previous chapter we have done the electric potential, उसको भी revise कर लेते हैं. Electric potential is a physical quantity which determines the flow of charges from one body to another body. It is physical quantity that determines the degree of electrification of a body. Electric potential at a point in electric field is defined as amount of work done in moving without any acceleration a unit positive charge from infinity to that point against the electrostatic force irrespective of the path followed. WAB line integral dl of electric field from A to B negative sign is equal to q naught divided by 4 pi epsilon naught 1 upon RB minus 1 upon RA. Here what will we do? We will take this RA equal to infinity and RB equal to R. Then this equation is divided by q naught, both sides divided by q naught. Then this become W infinity to the B divided by q naught will be equal to q divided by 4 pi epsilon naught R will be equal to the potential V. And its electric potential have the unit volt or joule per coulomb or Newton meter per coulomb. Electric potential at a point is 1 volt if 1 joule of work is done in moving a 1 coulomb charge from infinity to that point in the electric field. Electric potential difference. Electric potential difference between any 2 points in electric field is defined as amount of work done in moving without any acceleration a unit positive charge from one point to another against the electrostatic force irrespective of the path followed. ये सारी बातें हमने पिछले लेक्चर में की थी. तो यहाँ से हमें ये पता चलता है कि इलेक्ट्रिक पोटेंशियल दैट इज अ scalar quantity, electric potential difference that is also a scalar quantity, and electric potential at infinity that will be 0. And electric potential near an isolated positive charge is positive, and that near the isolated negative charge that is a negative. CGS unit of electric potential that is stat volt. Then we come to our topic that is electric potential due to point charge. Before discussing that, we will discuss the point charge. The point charge, such as electron, are among the fundamental building block of the matter. Furthermore, the spherical charge distribution, like on the metal sheet, a metal sphere, the spherical charge distribution create external electric field exactly like a point charge. Electric potential due to a point charge is thus a case we need to consider using the calculus to find the work done needed to move a test charge Q from a large distribution away to distance of R from the point Q, and nothing connection between the work and potential. We can define the electric potential V at that point. Then come to the electric potential due to a single point charge. That is our topic today. Consider the point charge Q positive and consider another test charge Q naught at position P. Let Q naught positive be the test charge placed at the point P at a distance of x from the source charge Q positive. Then the force here on this test charge that will be equal to Q naught E positive, and that is acting radially outward, and it tend to accelerate that charge. To prevent the acceleration, equal amount of opposite force has to be applied on this charge. That will be minus Q naught E has to be applied to prevent the acceleration. Then the work done to move this Q naught from P to Q through the small displacement dx against this Q naught E is dw. Small work done for the small displacement, dw will be equal to F dot dx vector, will be F, that is equal to Q naught E, Q naught E dot dx, or it is a vector quantity. In the scalar term, it come out to be dw will be equal to Q naught E dx cos 180 degree. Dx is in this direction and force is acting outward. They have the angle of 180 degree, and then cos 180, that will be equal to minus 1, and that give the dw will be equal to minus Q naught E dx. Substituting the values, we come to the dw will be equal to minus Q naught divided by 4 pi epsilon naught x square whole multiplied by dx. Because this E have the value Q upon 4 pi epsilon naught x square. This is a small work done. We can calculate this work done for the position A to B also. We can take the two positioning, and like the previous chapter, we can have the two values for the potential difference. The total work done to move this Q naught from A to B, we take it to the infinity to the R. We take this A at infinity and another position at B, that is at R. W infinity to B will be equal to integration of dw from infinity to B will be equal to minus integration infinity to R of Q naught divided by 4 pi epsilon naught x square dx, and that we take this outside because these values are constant. Here one mistake is this x square will not be there, it will be inside only. The whole thing come out to be equal to this Q naught will be divided by this, then W infinity to B divided by Q naught will be equal to Q upon 4 pi epsilon naught R. Omit this x square here. Then this is the potential V will be equal to Q upon 4 pi epsilon naught R. It is usual to consider the infinite as a point having zero potential. We have assumed that potential at a point that is infinite distance from the charge Q. To write the electric potential with respect to infinity at some point P at a distance here the x or R, we take this to the R distance. To write the electric potential with respect to infinity at some point near point R from this Q, we assume the this equation to be at some near position, and the electric potential come out to be equal to V is equal to Q upon 4 pi epsilon naught R. Electric potential, that is a scalar quantity. While using the this relation, previous relation of potential for the point charge, we need to consider the positive and negative sign of a charge. Potential at a point due to positive charge is positive, and at an it is negative for the negative charge. Then we come to the next topic, that is electric potential due to group of point charges. For that, we consider a point charge at position P and have the number of charges Q1, Q2, Q3, Q4, Q5, etc., etc., having their respective position R1, R2, R3, R4, R5, and Rn. Then the net electrostatic potential at a point in the electric field due to group of charges is algebraic sum of their individual potential at that point. What we have said, the net potential at a point in electric field due to group of charges, there are the n number of charges, then electric potential at here will be equal to the algebraic sum of their individual potential at that point. If these charges have the individual potential V1, V2, V3, V4, etc., then total potential at this position P will be equal to summation of the total individual potential V1 plus V2 plus V3 plus V4 plus and so on up to the plus Vn. Then after summing up, V will be equal to 1 upon 4 pi epsilon naught summation I is equal to 1 to n Qi upon Ri. This is the generalized equation. Because of the first charge Q1, potential will be equal to V1 and that have the value 1 upon 4 pi epsilon naught Q1 upon R1. Similarly, for the potential because of the Q2 will be equal to 1 upon 4 pi epsilon naught multiplied by Q2 upon R2 and so on. The total potential that will be summation. V will be equal to 1 upon 4 pi epsilon naught sigma I is equal to 1 to n multiplied by Qi upon Ri. In the vector term, position vector, in the term of position vector, the V will be equal to, potential will be equal to 1 upon 4 pi epsilon naught sigma I is equal to 1 to n Qi divided by Ri vector minus R vector minus Ri vector whole magnitude. Electric potential at a point due to charge is not affected by presence of other charges. Potential V that is inversely proportional to the R, whereas Coulomb's force that is inversely proportional to R square. Potential that is a scalar quantity, whereas force that is a vector quantity. Although potential V is called potential at that point, it is actually equal to potential difference between the point R and infinity. Electric potential at a point due to system of charges can be calculated by finding the algebraic sum of electric potential due to the individual charges. It was for the study, and then come to some example of electric potential due to the point charge. Here is an example. Question is that magnitude of electric field intensity and electric potential due to point charge at a point is 72 Newton per Coulomb and 36 volt. Calculate magnitude of the charge and distance of point from the point charge. Question क्या है, ध्यान से सुनिए कि magnitude of electric field intensity that is given is 72 Newton per Coulomb and electric potential due to point charge that is given is 36 volt. What we have to calculate? We have to calculate the magnitude of the charge and distance of point from that charge. Then we know that electric field intensity due to the point charge Q at a distance x that is given by E is equal to 1 upon 4 pi epsilon naught multiplied by Q by x square. Now the electric potential due to point charge Q at a distance r from it, that is given by 1 upon 4 pi epsilon naught Q by x. This is for the electric field intensity, this equation 1, and this is potential, equation number 2. Divide these two equations. Divide this equation 2 by equation 1. Then V by E will be equal to x, because 1 upon 4 pi epsilon naught and 1 upon 4 pi epsilon, that will be simply cut out each other. Q will be also be cancelled, and from this x square, single x will be remaining there. Then the total V upon E will be equal to x. V have the value of 36 and E have the value of 72. After division, this come out to be equal to 0.5 m. Okay, this is the value of x. Substituting this value, now substituting the value of this x in equation number 2, here we substitute this value, then this come out to be equal to Q will be equal to 2 into 10 to the power of minus 9. Okay, and that will be equal to 2 nanocoulomb. That is it. The second example we take here. Charges in static electricity are typically in nanocoulomb to microcoulomb. Charges in static electricity are typically in nanocoulomb to that of a microcoulomb range. What is the voltage 0.0 centimeter away from the center of a 1 centimeter diameter metallic sphere has a minus 3.00 nanocoulomb static charge? Read this question again. It says that electric charge in the static electricity that varies from typically varies from the nanocoulomb to that of a microcoulomb. And what is he asking? What is the voltage? Asking the voltage have to be calculated for what? 5 centimeter away from the center of a 1 centimeter diameter metallic sphere. कहाँ कैलकुलेट करनी है? 5 सेंटीमीटर अवे. किससे? 1 सेंटीमीटर डायमीटर मेटल स्फीयर से, और जिसके ऊपर चार्ज क्या है? -3 नैनो कूलम ऑफ स्टैटिक चार्ज. To solve this question, what is the strategy there? As we have discussed in the electric field, the charge on the metal sphere spread over uniformly and produce a field like that of point charge located at its center. Okay, then solution is that entering the values from this expression given in V is equal to KQ into R. In this is the equation for the potential. This is expression for the voltage, sorry, potential. V is equal to KQ into R. This is the value of K, 8.99 into 10 to the power of 9 Newton meter square per coulomb square. This is a value of the charge, -3 into 10 to the power of -9 coulomb, and the value of the R distance, that is 5.00 into 10 to the power of -2. After doing the mathematical calculation, simple multiplication, it come out to equal to -539 volt. Now the discussion is that negative value of the voltage means the positive charge would be attracted from a larger distance. Since potential is lower, that means more negative than at a larger distance. Conversely, negative charge would be repelled as expected. Now the summary of this lesson. The line integral of electric field. Negative line integral of electric field represent the work done by electric field on a unit positive charge moving it from one point to another in electric field. What is electric potential? Electric potential at a point in electric field, that is defined as work done in moving a unit positive charge from infinity to that point against the electrostatic force, irrespective of the path followed. Now the electric potential due to single point charge. Point charge such as electron are among the fundamental building block of the matter. Furthermore, spherical charge distribution create external electric field exactly like a point charge. Electric potential due to a point charge is thus a case we need to consider using the calculus to find the work done needed to move a test charge Q from larger distance away to the distance r from a point charge Q, and noting the connection between the work and potential, we can define the electric potential V of a point charge. Electric potential due to a single charge, we have calculated that electric potential due to single point charge V is equal to Q by 4 pi epsilon naught R, and electric potential due to group of point charges that have the definition: the net electrostatic potential at a point in electric field due to a group of charges is algebraic sum of the individual potential at that point. Now in the next day plan and next day study plan is that electric potential due to electric dipole. We will discuss the electric potential due to the electric dipole in the next day study, and electric potential at a point on the axial line of electric dipole will be calculated, and similarly the electric potential at a point on equatorial line of electric dipole will be there in the next day study. Thank you for watching the video.